For our last video for Chapter 1, I'm going to discuss a concept known as dimensional analysis. And this is a technique that you are going to want to master as much as you possibly can. Because this can really help you throughout the rest of the semester. What dimensional analysis is it's a method of trying to solve word problems using units first. And a lot of times students will try to just power forward with the numbers and plug them in into certain ways and see if they get a number that makes sense. But actually, if you're not sure how to solve a problem, using the units will actually be way more helpful than the numbers ever would be. In terms of trying to figure out how to set up your math to solve the problem accurately. So if you're ever in a pinch moving forward and you don't know how to solve a problem, look at your units. Try to go through with the units first, and if you can figure out how to get the proper unit for what you're looking for at the end, your numbers will follow suit. So here, let's do some examples, and hopefully you'll see what I mean. So, let's say, for instance, that the great quarterback, Josh Allen, weighs about 230 pounds. And I want to know how many kilograms that is. So, there's a known conversion factor between the two, that 1 pound equals 0.454 kilograms. That's a conversion factor, because a conversion factor is something that relates two different units to each other. So it's a known value, and on the sheet I've mentioned that we'll have a lot of known conversions and equations that will be on Blackboard. This is definitely going to be one of them, so you will not have to memorize this, because conversions like this will be on that sheet, and you'll be able to use that for exams and quizzes, homeworks, what have you. So now let's say, okay, you know this conversion factor, but mathematically, what do you have to do? Do you have to multiply? Do you have to divide? I don't know. So this is where units can come into play, right? So if you're not sure, look at the units first and try something. So let's say we want to, anytime you have a unit like this, pounds, that is not a fractional unit, you can basically think of that as being, that number as being over 1, right? So it's like, say, taking 230 pounds over just 1. Now, if we don't know how to set up this conversion factor, let's try it. So let's say we're going to set, conversion factors are always going to be set up as a fraction, and you can set up however many conversion factors you want. So let's just look at units first. So let's say 1 pound and 0.454 kilograms. So the way I have these units set up is basically with this kilograms being in the denominator. It's effectively like I'm saying that we're dividing by that conversion. Right? So when you do use conversion factors, whether you do just two numbers or whether you have 1,000, it doesn't matter. When you get them all lined up in a row, then the way you can solve the problem, you just multiply every numerator by each other, you multiply every denominator, and then you can divide those. So let's just look at the units. Let's multiply the units. So we have pounds and pounds. So that gets us pounds squared. And this is no unit, and that's kilograms. So that's pounds squared over kilograms. Is that the final unit we want for our answer? No, that unit doesn't make any sense. Right? We're looking for kilograms, and this is not that. So what that tells you is that this is not the proper way to set up that conversion factor. So let's try flipping it and putting kilograms on top. And we can do this because, remember, if you're flipping a fraction, basically all you're doing is you're just switching between multiplication and division. So let's say we have 230 pounds. And again, just to make it easier to see, I'm going to put that over 1 again. So now we've got 0.454 kilograms on top and 1 pound on bottom. Right? So now let's look at the units. So I've got pounds times kilogram on top. We've got nothing here, and pounds. I'll put that right there on bottom. And at first blush, you might look at this and say, well, wait, that doesn't look like kilogram either, because we've got the extra pounds in there. But anything divided by itself is 1. 2 divided by 2 is 1. Right? And that holds true for units as well. So if you see the same unit in the numerator and the denominator, like we have with pounds, you can basically divide it by itself and they cancel each other out. because they basically just get taken out as 1, and it's like you're multiplying kilograms by 1. So this actually is kilograms. That is the unit we want. So now, we know that we have this set up properly. The numbers will follow suit. So now just multiply all the numbers, so the numerators, by each other, 230 times 0.454. And multiply each denominator, 1 times 1. And so that will get us 104.42. But remember, conversion factors do not get used for sig figs, so the only number that we're going to use for determining sig figs is this 230 that we start with. And since there's no decimal present, we only have 2 sig figs, so we have to round this to 104. And of course, never ever forget your units. 104 kilograms. That is how much greatest quarterback in the NFL, Josh Allen, weighs approximately in kilograms. Okay, let's try another one where we have multiple conversion factors. So let's say we want to know the greatest cornerback in the NFL, Tre'Davious White. He's approximately 6 feet tall. He's actually 5'11", but for the sake of this problem, we're going to use 6 feet because it's a little easier. So if I say he's 6 feet tall, and I want to know how tall that is in centimeters. Do you know a direct relationship between feet and centimeters? If you do, then feel free to use it. Probably don't, though. However, you should know that 1 foot equals 12 inches. And so now I do want to pause momentarily, and I want to say that if a very common conversion like this you might not be given some super common conversions like that, because something like that you could be expected to know. And then also 1 inch equals 2.54 centimeters. So although we don't know a direct relationship between feet and centimeters, we could get feet into inches and then inches into centimeters. So let's do that. So here, I'm going to put this over 1 again. So if we're trying to get rid of the unit of feet and get into inches, so any unit that starts in the numerator, like feet is here, if you're trying to cancel it out, you need to put it in the denominator of your conversion factor. Right? So feet has to go down here, and inches up here. So we know 12 inches in 1 foot. And if you're setting up large conversion factors, it can often be helpful to cancel out units along the way. So now, if you look, as of right now, we've got feet in the numerator and feet in the denominator. So those cancel each other out because anything divided by itself is 1. So if you want to cancel along the way, that can help you, because now just look at any units you don't have canceled out. In this case, it's only inches. And that means that your current unit, after doing this math, is inches. So it's just a way of keep track of your units. So now we're in inches. We have to set up another conversion factor to get into centimeters. So now we need to cancel out the inches that we just got. So inches is in the numerator, so we have to put in the denominator of this next conversion factor, which means by default, centimeters goes up here. So we've got 2.54 centimeters, 1 inch. And if you want, just to double check your work, inches in the numerator, inches in the denominator, leaves us with just centimeters. So now we can multiply every numerator. 6 times 12 times 2.54. And we can multiply every denominator. 1 times 1 times 1. It won't always work out that nicely, but sometimes it will. So that gets us 182.88. But we have to look at sig figs again. Remember, these two conversion factors, those are known conversion factor values. Those do not get used in sig figs. So just this 6.00 is going to be used. And these trailing zeros are significant because we see that decimal here. So that's 3 sig figs. So round this to 3 sig figs, and you get 183 centimeters. So one point I do want to note before I talk about the next thing. So let's say you get something like this. So you have inches squared in the numerator and inches in the denominator. Can you cancel those out? And the answer is partially. So remember, inches squared is basically the same thing as saying inches times inches. So it's like inches times inches over inches. So you can cancel out one of these inches with the inches in the denominator. The other one you can't, right? So basically, if you have exponents, so different amounts of these units, you can keep canceling out until you run out in either the numerator or the denominator. So this would cancel out to just inches in the numerator. So the last thing I want to talk about for this video is that this is one way to write conversion factors, right, with an equal sign there. Another way is to use a unit, a fractional unit specifically. So for instance, let's look at density. So density is calculated as mass divided by volume. So if you have density, its units are always going to be some kind of mass unit divided by some kind of volume unit. And it can be used as a conversion factor between that mass unit and that volume unit. So for instance, the density, so let's say the density of seawater is 1.03 grams per milliliter. Right? So grams is the mass unit, milliliter is the volume unit. And another way of writing that is saying 1.03 grams over 1 milliliter. And this kind of shows you how it can be used as a conversion factor. So now let's say I want to know how much volume 250 grams of seawater takes up. So I'm going to start with 250 grams. I'm going to put a decimal there to give us 3 sig figs. Right. And how much volume does that take up? Well, so let's put this over 1 again. Now we can use this conversion factor. So we want to cancel out grams and get into milliliters. So if grams is starting in the numerator, we have to put it in the denominator of our conversion factor, which means milliliters has to go up here. And remember, the numbers have to stick with the units they started with. So 1.03 now goes down here, and the 1 up here. We can cancel out. You don't have to cross out units if you don't want, but it certainly doesn't hurt, right? So now we're left with just milliliters in the numerator. That's exactly the unit we want. Right? And remember, basically putting this 1.03 in the denominator is basically just saying we're dividing by it. And we can actually see that because, again, if we just now multiply all the numerators across, we get 250 times 1. Multiply the denominators across, we get 1 times 1.03. That equals 250 divided by 1.03. We basically just end up doing that division, and we get 243 milliliters. So that's another way that you can see a conversion factor with fractional units.